Hello, my dear AQA Computer Science 2026 students. This is on Simulator, specifically ZigZag Task 7. Now, this is the one where I'm actually warming up to the ZigZag task because individually they're not much, but seen as a progressive structure, it's starting to make sense. In the previous task, we made a flying ant, so we had to learn about the way ants are birthed by the queen, as opposed to initially set in the nest, which is a different thing, and the basics of the advanced stage method of the simulation in which many of the important things happen. On this one, it's also a new type of ant, so new subclass to the ant class. It's a forager ant. We're creating it differently, and it works differently. So this one will actually move with kind of do simulated motion, whereas our flying ant will just teleport to the right cell. So without further ado, let's copy. Ooh, this is big. And paste, and I can use the keyboard to rename. This is Z7. And we're in the right place. So first up, we need to do a. So I'm going to use the outline a lot, I think, on this one. Not main, not none of this thing. Yes, we're getting there. Okay, so after workaround, so above nest. Oh man, this is no, that's the nest. Okay, can I just a tiny bit smaller? Sorry if you're on your phone, but where am I? The nest culling code, and here class and Q. WorkerAnts, and it's actually the WorkerAnt, as it turns out, behaves exactly like the WorkerAnt. So if we go back to the brief, so a bit, this is kind of more like the classes. Modify any base classes required to allow the WorkerAnt to operate. I did not need to do that, but I'm guessing there's a solution that does do that. This is more kind of, we acknowledge there's more than one way to do this. So like, you don't feel constrained by having to change something we haven't specified, we being ZigZag here. So it moves randomly like a normal WorkerAnt. That is, normal WorkerAnts will move randomly until they smell a pheromone in an adjoining cell. Then they will follow this pheromone trail just by kind of smelling a stronger one in the next cell, and until they find food. And once they have food on their back, they're always heading for the nest. So move randomly, but smell food sources. But it can only smell them within the immediate neighbors. Carrying carrots to 30, like the WorkerAnt, the smell of food should add a value of 10 times the amount of food in a cell, whatever. The food source, yeah. Right. The food source is one of the forager neighboring cell. The food ant moves towards it. A forager ant collects food and takes it back to the nest as normal. So all of this is WorkerAnt stuff. There's just like the way it moves might be slightly different. So without further ado, we were here. We want a forager ant that inherits WorkerAnt. It's got the constructor is, just your basic dunder in it. Oh, look at that. It's already done for me. But in addition to this, food capacity 30 will come from this, but I'm going to have a type of ant called Forager. And then I'm going to maybe need to move a little bit differently. I'll just leave that for now because I know that's the only another one I'm going to touch, but that was it. So where are we? Bird? No. What's happening? 7. When the nest is set up currently, it adds one queen ant and an amount of WorkerAnt to create one less. It's actually fewer WorkerAnt, one WorkerAnt fewer, and add a forager ant. So when the nest is set up, it's actually not in the nest class. It's in simulation. We have something called setup nestat that will set up the nest, create a queen, and then it starts. There's the number of ants, starting ants in nest, include the special ones, including the queen. And so it starts counting at 2 and then goes up to the string. So all we're going to be doing here is self._ants.append bracket Forager round bracket. Same deal. Takes the same parameter, right? It needs to know where to create it and where the nest it came from is. The only thing different in the constructor is the type, right? The signature of the constructor hasn't changed, and then here we're going to make it start at 3, which means there's going to be that bit done. Fair enough. Now note this is not in the nest. The queen actually giving birth to the ants is in the nest class. The starting ants that are a parameter of the simulation that the nest starts with, that's in the simulation class. So we've done this. Update the cell class to introduce the concept of the smell of food. Now this is where you see that obviously the task is for pedagogical value, because you're learning that kind of learning your way around the code, like what bits do what, rather than the value of the features of the simulation, which I think is maybe more obvious in a simulation than in a game. In that instance, so all that's going to do, really, I barely need a method here. So the forager ant sounds special, but like it's less good than the worker ant, because the worker ant, at least when they find a pheromone trail, they go to the food, whereas the forager ant will just kind of wander randomly until it's into a get amount of smell to keep the naming convention. And here I'm not even going to have I'm not going to have like an attribute that I update and so on, since it's always 10 times. So that's just that. That's done. And create a new method. Yes, no, this is important. Now, okay, the way your worker ant normally move in simulation, and in the, can I split it? Can I like reopen it? Oh, split right. Yeah, it's cool. All right, so on the simulation, yes. In simulation, there's the advanced stages, which is, I should have folded these. There's probably some, yes, there's probably some, okay. And here, I'm going to want to be in ONT. Actually, I'm going to want to be in WorkerAnts. Choose cell to move to. Okay, so and for this, yes, we can almost see all of it. Right, so when it goes over the ant, don't know how it deals with the queen, don't really want to know, forgot, doesn't really matter, but it advances their stage, so they kind of take one click of age, and then they get the current cell. This is, okay, so if it has some food, we just, and it sets it at its own nest, we transfer the food. Otherwise, there is food in the cell, and it's otherwise pick up some food. Otherwise, the moving is if it has some food on its back, it lay a pheromone and chooses cell to move. Now this is going to automatically decide, oh, I've got food on my back, so I'm going back to the nest. We still pass this though, and so that's why we pass this in both cases, whether it food on its back or not, because we have this get index of the neighbor with the strongest pheromone that we may or may not use, and if we use it, we're just going to move that way. So we want to be doing this again with the workaround, and this is going to take a list of neighbors. So there's the list of, I'm pretty sure it's indices of neighbors, like the codes of neighbors, like the indices in the main grid. And then which of this, so this is not an index in that list, it's an index in the grid. So what is the grid index of the strongest pheromone amongst these neighbors? And then there's a way of, this will move and use, this is important. We'll figure out which one from this and then change cell index to use, which this tells us where in the list of neighbors that number is, right? And this becomes the index to use, which is that moving logic that you have here, because the same numbers, this is how you pass to the move end function, which I guess is in the regular round, not the worker one, which change cell. No, there's a change cell that's an internal one, and you have, come on. I know, that's the one, yeah. Change cell, new cell indicator, that's the code. And then it will kind of decide whether to change the row or not based on what number it is. So if it's 4, it's not going to do anything. Okay, so now that we know, we have considered those things, let's see how we make it happen. If a dot get type of ant is equal to Forager, we are gonna do the same thing, the exact same thing, except instead of calling get index of neighbor with the strongest pheromone, always pithy method names in the AQA word, very, very concise. Instead of calling GINWSP, we are going to go, it's just we want the same thing except the smell at the end. And in fact, this, if I just search for this particular method in the simulation class, too big, I'm going to want something that's pretty much the same thing with one minor difference. Pheromone actually much more complicated than smells to handle because we have a direct accessor to this. There might be more than one pheromonal trail laid in. It's complicated, right? Pheromones are stored in an array and they're just kind of laid by ants, obviously, and so there might be more than one pheromone trail in a cell, and so you only want whichever is the strongest, and this is more complicated to get half pheromone. So whereas if you want just smells, then you're interested in, I need to close this, making it orange. Ooh, strongest smell. Now, it's a finding of the maximum. What's the strongest smell? Where is it in the index? And for each of this, so the difference is here. This is the stuff that gets us for so for all of the indices of the neighbors, right? The indices in the main grid, which is where we access it. That means that's the neighbor, and then we find the strongest. This is the strongest smell in the strongest pheromone in the cell. This becomes self._grid. So at index. Index here is where am I in this list of neighbors? So for whichever of these neighbors has, and I use my new method, which is get amount get amount of smell. Oh, I should have control D this, right? Because this is also here. Then we also replace it. Oh, get amount of smell. Of course, yeah, do not forget, right? Even if the method doesn't take any argument, you still need the bracket. And under stressful exam circumstances, people have been known to forget them, and then you get the can't compare an int and method. Like the fewer time you can launch you run the code and it crashes, the one less iteration of that loop is always good. So the more you can preempt, get it right first time. So check your linters, because that's not detected by, it's not a syntax error because this is actually valid Python. That's slightly misleading, but yeah. So that's my index of strongest smell, which works exactly the same way. So this is what is the index in the grid of the neighbors of this row column that has the strongest, in that instance, smell. And this means it's going to be the food where it is. Why did we not just check index of the neighboring food amount? And why do you have to multiply by 10 is beyond me. But it's just kind of, they want you to get a sense of the code, obviously. It's not for the thing. And then simulation class returns the index as strongest, and then to direct the Forager end, I believe we had done that, right? This was in, I'm going. Yeah, I need to take care of my voice if I'm going to be doing I'm a live streamer, I'm speaking very fast and doing some kind of things on the screen. Yeah, twitchy. They call it Twitch for a reason. Just yeah. Right, okay. Have I had my ADHD meds? No, let's do it live. So the simulation will take along the simulation in advanced stage, right? This is where we were, and this is where, as we iterate over the ons, we also have checked whether we're looking at a Forager ant. This time we're doing it after the whole stuff, right? Remember for the flying ant, I would have put it in here and then skipped all of that bit if we kind of, it's a flying ant. But here we want to do all of the kind of pick up food and take the food back home, because the Forager ant does all of this. The only thing that's changed is the way it gets to the food in the first place. So this is, I think that's fine. I think that, oh no, wait, and we also need to tell the user what direction it is coming from your neighboring cell matrix. So, this is the thing where I left it out for later. If I go and search my class Foragerant here, before I do this, yeah, okay, so I'm going to want to list, I'm going to want to take the directions, cardinal directions. I want to mimic this in an array, so I can just kind of look up a cardinal direction. don't go into like if for ifs. So it's north. Yeah, it's everyone's favorite celebrity daughter, Northwest. I believe the daughter of Kanye West and one of the Kardashians. The OG Kardashian. What Kardashian am I thinking of? West. Index 4 means your home, so I'm just going to say none because we shouldn't really have anything here. I'm going to put a clause in here, and then we go to the east, the southwest, and the south and the southeast. Which you can put things in between things by selecting the things you want to be in between the delimiters and then pressing your brackets or quotes. It's quite helpful. Lots of even the Raspberry Pi Online IDE does that. It's like Control D. This kind of good mapping. Right. So we get all the directions, and then now remember the index of the neighbor with the strongest pheromone. It's not an index in that kind of grid stuff. It's actually an index in the larger grid, like simulation dot underscore grid, which is this array that stores the grid. So we will need to say and you access it. What is this index 2? Do I want to do this? Yeah, whatever. Yeah, that works. Because this is exactly the same thing. So this time I want to say, right, so which of these, right, do I want to be using? Like where in that list of neighbor is it? And this is going to tell me, because the neighbors are arranged in that order. I hope so. Yeah, of course, because this is how we move to them, right? Which is the same thing we used to move to an actual, like, northwest, whatever neighbor, is the thing we're going to use to just print a message to the user. Forager on smelling food to the, and then comma and directions, and read this at index to use. Much simpler. Okay, I could have compacted this into online, but with the length of the variable names and stuff, it makes it a little bit more readable. Okay, we test. Are we testing? 1, 2, 3. Oh, I was something running probably. Oh my god, there've come so many. Okay, I just real quick. Just I don't need all of those terminals. That's an old one, and run it. It's not crashing, which is nice. If I display the overall area details to see the overall details of the area, the nest, the aunts that start with the nest are still viewable. So if I inspect my good old the 2.4, look at that. I have a forager aunt, and then let's advance it by one stage. Oh wow, it's already smelling to the non. Yeah, I want something a bit fancier than that. Sorry, yeah, I forgot about this. So the non, we shouldn't. I also want something that's not a -1 as well. Oh man, this is ugly as, but okay, fine. If that shouldn't be -1 because it means we couldn't find one. As long as this is not equal to -1, then all of that stuff, and actually this. Also, if the index is not the one in the middle, because we shouldn't. I mean, I guess maybe we might be on the cell when it picks up the food. Whatever, will it have time? I'm not sure. Probably could actually. So that's probably where it came from. So we're not the non, but yeah, non was here. Yeah, the nest has food that smells probably. Okay, we're back here. Let me test it now. Testing. 1, 2, 3. Okay, up. I appear to have damaged my code. Yeah, -1, not minus exclamation mark. Oops. Okay. No, still no. Yeah, okay. Not with it today. So yeah, don't do this in the exam. That just wastes time. You will not have obviously a task like this in the exam, but wait, smell food. It's about it's a bit weird. It seems to be smelling food all over the place. Is it? I mean, which of the? Okay, well, let's inspect. Not this one. Not that one. Obviously, there's the queen. It's going to stay there. The forager is carrying 0 food. So where is it moving? I wish we could keep track of it. So it is in 5-2, in 2-5. Sorry. Let's advance by 1 and redisplay. Is it stuck there? I really hope. Oh no. Oh man, come on! Don't tell me I've done some broken thing. Okay, well, I'm nearly there, right? Like for the mark scheme, I would get. Come on. All right, this is like the bonus part where we debug that, but I'm not happy because it was okay. Let me have a look at the diff. Is it because I misindented that? Suddenly it's in. Yeah. Where? Oh. This. So in advanced stage, we kind of pass the smell, and then it should still kind of move randomly. It should be in this in its random move mode, which is directed by this, right? That's if it gets a food, it goes back to the nest. If it's -1, we just choose a random neighbors from the list of neighbors. Maybe it's a problem with that, but like wouldn't. In fact, we're going to put some breakpoints. Okay, but just this is a fiasco. This is a disaster. This is a disaster. Okay, the diff. This is how we create it. There's no problem with that. My get index of neighboring strongest smell. Same principle, except we use get amount of smell on the grid get amount of smell on the cell. It's a new method that we have created in the cell class. What's this? This is how we move the forager. So maybe this is the problem. No, we get the indices of the neighbors at this place, yeah, and then I should. That's my problem. I need an else here. That's the problem. It's doing both, and this is confusing it. Of course, right? So else, it's not a forager, meaning like at this stage it's going to be a worker. I don't know. I can't comment about the queens. Maybe there's going to be some questions about queens where we can kind of find out. So yeah, I'm sure it works now. So we could just show you to dev, but like I can test it for the sake of it. But you've seen it move. You've seen it kind of get its message. It wasn't doing it in the right way. Just to wrap it up, the diff here is like this. Compare. Right. So we created in the nest. It's not spawned by a queen. This is to find the strongest smell. It's the same as the pheromones, exactly, except the way we find the value we're looking for, that we might try to maximize, is different. That comes from, I'm guessing, this guy, the get amount of smell from in the cell class. And we have this new foragerant, but they never tell you, like, a new Forager class, any base class is required. They never tell you like make a child class to the Forager, but to the Forager should be a child of the WorkerAnt class-wise. And so if you re-implement all of that code by hand, you're in a pickle. And nothing. The constructor just set the type. And the only thing we do before we call the moving logic is here. Literally, all of this code is just to print the message. And this is a good illustration of the idea of the way it kind of passes a list of neighbors, it's actually a list of indices in the grid array of the simulation of neighbors. And then which, again, index in the grid array is the one that, or maybe -1 if there's none, but like if there's one that is the strongest pheromone, or I call it pheromone because that's the parameter here. That should really be well, no, that could be smell. That should be smell here. I could probably do this now. boils down to exactly the same, but that's because I copied and pasted. But if you want to be precious, yeah, oof, oof, not non-press return at the end. And that was it, right? Kind of new class, a bit of touch to the cell class, setup in the nest, minimal, actually, ultimately minimal amount of, this is the candy index, minimal amount of messing around. This is good news, by the way, with the advanced stage in the simulation, which is where a lot of stuff happens. I'm a bit, I don't know how appropriate it is that the logic of moving a workaround lives in here, because part of it lives in elsewhere. Well, that's kind of, sorry, that's actually the logic of, the picking up is what annoys me. The picking up is here, whereas like the deciding whether to move back to the nest is in the elm. That's fine. That moving the food to the nest, giving food to the nest is in here. I mean, maybe this is the remit of the simulation. I guess, am I pointing in the right side on my screen? I should be here, right? So maybe that's it. But I think that it should. This is where the point of this task, right, is we kind of learn about the aunt classes, really. And so this is the one that moves it, that say, well, if I've got some food on my back, I'm going straight to the nest. And then this is, I do random unless there's a strong pheromone. And why wouldn't pick up, if you get food on your back, or this one, we're like, well, I don't have food on my back, surely picking up some food should be in here. But whatever. Anyway, this is how those tasks are a roundabout way of learning the structure of the code. And the best way to learn the structure of the code is to really do these tasks yourselves. And in fact, I think those videos are really too helpful, and because you think you understood, but like you really need to just wrangle it to go, this is how it works. Like, and every time I record a video, it is like in that instance, it took less long for me when I did it the first time. But you don't always forget the L's. There's a lot of things to get right. I hope that we'll have time to see each other again in task number 8, which is the next one.